Hi, it's Wayne Schaefer coming to you again from my basement workshop. Wanted to do something a little bit different today. Wanted to play with a little light I picked up at the dollar store. Reason being is a little while back I picked up this really nice headlight for my bicycle, and it cost me a great deal of money for something that was very bright and lasted for a decent amount of time, and had different modes on it. So I saw this at the dollar store and thought, oh, what the heck, let's try it out and see what it's all about. Okay, so it's just a light and a mounting bracket. On the back it shows you the modes that's available on this. And it looks like it takes 3 AAA batteries. So let's go ahead and put those batteries in and see how long they last. I think that would be the first order of business. Well, let's see how bright it is. First, go get some batteries. I'll be right back. Okay. Let's put the batteries in. Be really surprised if it's really bright. Okay, so let's press button, turned on, and oh, actually it looks pretty bright. I'm not going to look straight into it; that would be a bad thing. But it looks like it's got a very bright LED on it. If I press it again, it goes to a dimmer mode, and press it again, and you get a flashing mode on it. So it's actually kind of neat. If I press and hold, it's got a different mode where the rear light lights up and gives you kind of a lower intensity flood. So actually from that standpoint, it looks like it's pretty bright. It's kind of surprising. Maybe not as bright as the one I bought, but let's or one I bought from a bicycle beforehand, but let's see what happens. So I'm going to use my light meter here, and I'm going to get a stopwatch, and we're just going to turn this on and let it shine at the light meter and see how long the batteries last and how long the light. Being this bright, I suspect these batteries aren't going to last too long. AAA batteries are only good for about 1,000 milliamp hours with moderate load, maybe 10 to 20 milliamps. So this looks like it's drawing a heck of a lot more than 20 milliamps. So let's find out how long it's going to last. So that means I need to go find my stopwatch. So let me go see if I can hunt my stopwatch down. Okay, so I got my stopwatch, got a light meter. So I'm going to stop it there and get this set up so you can see the light meter reading and the stopwatch at the same time, and we'll see how this works. Okay, so I've turned the light on and I've adjusted it for the largest value I could find on the light meter. Start the stopwatch and let's see what happens to the light level over time. Well, you can see from the testing that the light output of this dropped quite a bit during the initial test with brand new batteries, first out of the box. Then I thought I'd replace the batteries and try it again, but the light output is still low. So let's take it apart and see what's in this thing. I'm worried a little bit that maybe we have a module in here that's overheating or is self-destructed in some way, which is very odd because I only ran it for 2 or 3 hours. And I replaced the batteries and light output was still half of what it was when I first started this. So let's see, this probably comes off nicely here. Okay, looks like there's a few screws in here to take out. Okay, not a lot to it. Small circuit board. diffuser, reflector of some sort for the rear light. And the front light. Oops. That over there. Okay, it has a small LED module in it. And it is tagged, or it's got a tag on it, YD1. So I'm kind of familiar with that one. That's a 1 watt LED mounted to a star heatsink. So my concern now is that maybe this overheated. See, there's just a little pad back here to hold the heatsink away from this plastic, but depending on the LED, maybe that's not enough of a heatsink for this. So we're going to do some testing on this LED, see what voltage it runs at, and see what temperature it gets to. If it's already destroyed, then of course we're kind of out of luck here. But let's take a look at what the condition is currently. So I'm going to go ahead and put the batteries back in. Take a quick look at this. Just want to see what the voltage drop across the LED is. These LEDs maximum voltage drop is about 3.4 volts. Let's go ahead and hook it up to my meter. We'll do that and then we'll test the current. Okay, so let's just turn this on. And have a high precision multimeter over there, and we're reading 3.2 volts. So it's in the range. It's not max, but of course these batteries should be okay. But it's not a maximum voltage. It's about 3.2. It should be about 3.4, but not a major issue there. So the fact that its light output is so much reduced, but we still have 3.2 volts across it, is very disturbing. It means we've probably maybe burned out this LED already. Let's turn this off. And now I want to measure the current going to this. Okay, that means I need my soldering iron. I'm just going to unsolder that wire for now. Okay, so the soldering iron should be hot enough right now. And I got myself a little pad to set the light on. So let's take this wire off. Okay. And just move this over here. Change my meter over to milliamps. And we will take a look. I can get the lead on there. I'll try it the other way around. Oh, that's better. Okay, 360 milliamps. So 350 milliamps is the maximum current for this LED, so it's actually running at its rated current. Okay, so the fact that its light output is reduced means that this LED has probably been damaged somehow. Now, I'm suspecting that maybe this heatsink isn't big enough for the amount of heat generated by this LED. Some of these lights generate quite a bit of heat, and having the heatsink in an enclosed space inside the plastic body of the light here, probably not helping a whole lot. So we're just going to double check again here. So I'm going to put this all back together. I'm going to do just double check with a light meter. Try to keep it the same distance away so it's, I just move this till I get the maximum. 24,000, 23, 24, 25, 26. 27. Okay, so the maximum I'm getting is about 27,000 lux. Now, as you recall before, we started at 40,000, so obviously something's drastically wrong with this LED now. Now, all I did was right out of the box run it for a couple hours, and this is what's happened. So, okay, turn that off. I do have an idea. Okay, so I'll tell you what we're going to do. We are going to take a look at the temperature of that heatsink. So we're at 105 degrees Fahrenheit, climbing, and you can see the meter there. 140 degrees now already. This is climbing pretty fast, so that worries me quite a bit. 175 degrees, still climbing, which is going to be kind of warm to the touch now. And that is now so hot that it's burning my finger to touch it. So there you go. You get a dollar store light. You'd run it once, and maybe or maybe not, you'd notice that the light is not as bright the second time you're out biking and wonder why it is. You replace the batteries, and sure enough, it's still dim, and maybe now you're just blaming it on yourself, thinking, oh, maybe it's just me. Maybe this is what they rely on when they make these kind of products. I don't know, but it's annoying as all heck. Because now this one's basically destroyed. I would have to buy a new light and put it in there. Now, luckily, I did go out and buy a second light, and I did test this one last night just to double check my meter, and it was running at 40,000 lux. So I turned it off right away, just so it wouldn't do the same thing this light is. So 175.4 degrees, still climbing. Touching it is very hot. And again, it's not enclosed anymore, it's just sitting on my bench, so it's going to be a lot hotter inside the housing. So I think we can turn it off there. It's already at 175 degrees. If I make a power supply for this and I adjust it for 4.5 volts, I really think it's going to be, this is still pretty hot. I think it's going to be too much for this LED, so we have to be really careful when we design the power supply for it and adjust it so we have maybe 3.4 volts across the LED or 350 milliamps through it, whichever one we want to measure at the time. And also I need to figure out maybe a heatsink strategy for this so that this won't overheat inside the body of this light. So we're going to embark on a little project here. I've got another one I tested out as still being undamaged, so I'm going to take this one apart, put a heatsink in it, bring it to the outside, build a power supply that'll connect to a USB battery, which should, with 5,000 milliamp hour capacity, should last quite a bit when you're on a bike ride. So let's give that a shot.